Hi everyone, and welcome to the session on embedding security into your DevOps practices. My name is Farshad Abasi, and I'm based in Vancouver, BC in Canada. I'm an alumnus of the University of British Columbia with a degree in biology and computer science. I'm the chief security officer and founder of Forward Security. And prior to starting this company, I was the global principal security architect for HSBC Bank, as well as head of IT security in Canada. And I joined the company starting out as an application security consultant and moved on to managing the team and staying with the company for a number of years. In total, I've spent about 4 years now in IT. 12 of those, the first 12 after graduating university, were spent in software development and building systems and IT. And then I pivoted around 12 years ago into security as a full-time job. And in the beginning, I started out as an application security consultant, helping people that were building software build more secure software, which is the topic that we're going to talk about today. But before going into that, my first 12 years as a developer were spent in everything from doing C and C++ development to C# and Java and JavaScript and you name it, basically full stack development, as well as building various IT systems, including network systems. I'm currently an instructor at British Columbia Institute of Technology, teaching security, of course, and I also lead the OWASP Vancouver chapter. OWASP is the global application security organization. It stands for Open Web Application Security Project. I highly recommend that you take a look into all the resources that they offer, some excellent source of standards and events and local meetups in your area, virtual, of course, during these times. And I'm also a board member of the Mainland Advanced Research Society that organizes the B-Sides Vancouver Conference and other meetups, as well as being an avid music fan and food lover, which is quite important. So this today's presentation, the target audience are DevOps team members, product owners, and business analysts, as well as other IT and technical personnel involved in the application development lifecycle. And what we're going to talk about today is we're going to start by talking about why do you need to shift left? What does it all mean? What is shift left and why do you need to do that? We're going to look at how we went from Agile to DevOps and how we can get to DevSecOps and what that all means in relation to each other. And then we'll finish off by talking about how you could embed security into your DevOps practices. So why do you need to shift left? This should be familiar with most of you who have been involved in software development. Whether you're doing Agile or DevOps or whatever model that you follow, in general, the software development lifecycle has the following stages, starting out with planning, analysis, going into design, implementation, testing and integration, and then maintenance. These stages exist in various shapes and forms, and whether it's Agile or Waterfall or what have you. And software flaws can occur during planning. They can occur during design analysis. They can really occur during any of those stages. And there are various studies have been done. A lot of them are actually outdated. Most presentations like this show slides from studies that were done in the early 2000s or even before that in the 80s. However, as a generality, it has been demonstrated that the earlier you address the bugs or flaws, the lower the cost is. And as you can see here, if we address the problems or if we start thinking about security during planning, the cost is quite low. And as we go to implementation, test, and maintenance, if we address them as late as maintenance, which is all the way on the right, the cost is almost 30 times as higher had those flaws been addressed earlier or had security had been incorporated earlier into the cycle. So you can see here, shift left, right, pointing left on the planning stage, where right being on the maintenance stage. So that's where you want to do security. I mean, of course, you want to do security at all the different stages, but the idea is to incorporate it in every stage of the software development lifecycle. Because once a flaw has been built into the application and rolled into production, fixes are going to be quite costly, as you can appreciate. So shifting left, it results in much lower cost to address flaws early in the software development lifecycle, and the goal is to address security earlier, not to create more work for developers, and that's a key factor that we're gonna talk about later on in the presentation. And roles and responsibilities of quality and security don't go away. So just because we introduced this shift left model, we don't basically say, yeah, no, the developers are going to be responsible for doing everything. There are still responsibilities for security, and those remain. So let's talk about how we went from Agile to DevOps and how we can get to DevSecOps. So this diagram should be familiar for those of you who've worked in the agile in an agile environments. And typically, you start with initiation of a project. So during the earlier iterations, you figure out what are the overall requirements and what are we going to do, high-level architecture, and we create a backlog of work items, and then we do iterations. And during those iterations, we take up certain items from the backlog, and there are daily works and stand-ups and meetings. And the iteration, as the iteration goes by during the that cycle, an increment of software is the outcome, and that the software increment is reviewed and it's released into production, and then you get a working system, which is then put into operation and finally possibly retired. But oftentimes, once that working iteration of software is put into production, the team then goes back and picks up a few more items from the backlog and further works on those during the next iteration, and you repeat this process. So in Agile, the focus was on closing the gap between the clients and the developers. So previously, we had the dev team separate than the ops team, and the sec team, they were all separate, and the clients were also separate, and there was not enough integration. So that basically what would happen is there'd be this, in the waterfall model prior to Agile, a lot of teams would spend a whole bunch of time and with the customer, get a comprehensive list of requirements, and then hand it off to the development team, who would then work on building those features for the clients for a period of time, usually 1 to 3 years or even longer in some cases. And because of that disconnect, clients were not as integrated as part of the process, and the results were not as agile, if you will, from a business perspective. And by the time the team had finished building that software, the requirements had changed. So what Agile focused on is bringing the clients and the developers together and closing that gap so that the client is in touch with the dev team, and they can continually provide additional requirements or change requirements in an agile manner. What Agile didn't address was bringing the rest of the pieces or the rest of the team that are involved in the process together, namely ops and sec. And then so there was a move towards DevOps later on, where DevOps focused on closing that gap between dev and IT team and the IT ops teams, and then hence we ended up with DevOps. Now, DevOps inherited the automated build and test as well as CI/CD from Agile. So they're not mutually exclusive necessarily. DevOps focuses more on the delivery side, more on the IT ops integration, whereas Agile focuses more on the development and bringing the customer together and creating rapid processes where you could create working increments of the software and being able to continuously build, and a lot of focus on automation. So all of those things have been inherited. And in fact, a lot of the DevOps teams, they follow Agile software development methodologies. So what about DevSecOps? With DevSecOps, we now then said, okay, well, we have the sec team sitting, by themselves here lonely. So let's bring the security team as well and make it part of the process. So DevSecOps, the idea is to bring security closer to the dev and ops teams. And it's not a specific position in the team, or it's not a specific tool. You often hear that I'm hiring a DevSecOps position. It's more than that. DevSecOps is about culture changes, introducing practices and processes, and really forming teams where security is an integrated model. You will have people within the DevOps team that would be appointed as a security champion, and we'll talk about that in a bit. But oftentimes you don't have a dedicated security team member within that team. That's not to say that you can't have that, but oftentimes there are not enough security people to go around. So the common model is that you find someone within the team and appoint them as the liaison to the security team. So essentially, DevOps integrates security practices. DevSecOps integrates security practices into DevOps. And the security team must adopt a federated model, right? So you still have the security team that's supporting the DevOps teams and the champion within the DevOps teams, but because of the shortage of those people, the federated model is such that the security team member within that dedicated security team, their job becomes to provide support and mentorship and helping the person within the DevOps team who's been appointed as the champion or whatever position the title they've been given. And DevOps team is then enabled to factor in the correct security controls that would be required. So embedding sec into the DevSecOps, into the DevOps process, what do you need to do? So the key ingredients of DevSecOps are, of course, people, process, and technology, like a lot of other things. But breaking it down in terms of the people side, you need to break down those silos. So you need to essentially form your teams in such a way that within the DevOps team, as I mentioned, you have someone that is the security champion, and you have that federated model that they liaise into your security team. If you don't have a full-time security team, you can outsource that function. Or if your company is large enough, you can bring in a dedicated security person or team that supports all the DevOps teams or the champions within them. You also need to drive a culture of accountability. And that's quite important because the whole idea is to enable the developers and make them accountable rather than act as a police. In the old days, the security team would act as the cops and as a gate, and everything had to go through the security team, and that would slow down the agility of the DevOps process. The idea here is to have a culture of accountability and enablement so that you don't have to have that traditional policing and that separate silo. In terms of process, what you want to do is you want to have normalized processes, and you want to follow an approved dev path. So you want to create, across all of your different DevOps teams, you want to create a flow saying, this is how we're going to build software. Every time we do a pull request to merge into the master, there's going to be a bunch of security scans that will execute. And of course, this is the pathway that everyone has to follow. This is the pipeline that everyone has to follow. And that pipeline would have incorporated into it a certain number of security gates and practices. And keeping in mind that none of those gates and practices should break the agility of the DevOps model. You also want to establish governance policies, and what that looks like, again, not erring on the side of keeping things light and not introducing too many delays within the process, and while maintaining the risk profile that's appropriate for the organization. And last but not least, you want to add technology, and the technology is going to help you with automated testing and using, you want to use infrastructure as code. And really, automating your test for security testing is no different than what many DevOps teams do with respect to automating their QA. And in those cases, in many cases, that DevOps teams, what they have with their CI/CD is automated unit testing, automated integration regression testing, and all kinds of other things. You want to have security tests that are parallel and analogous to those different QA tests that take place during the DevOps lifecycle. And using infrastructure as code is quite handy, and it adds a lot of security. From a security perspective, if you codify your application, you basically vet the codified infrastructure. Sorry, not application, but infrastructure. You have the security team review it and make sure that it meets the right requirements and what the company needs from a security perspective. And once the security team has approved that this is that meets the security requirements for the company, then you put that under configuration management, and you ensure that any changes to that are then again reviewed by security. But as long as it stays within configuration management, you can trust that any infrastructure that gets deployed from that code that was created will have the right security controls in place. And this is good for another reason, is because you don't have to constantly go and test the infrastructure. Not to say that you shouldn't do that at all, but having this process where changes are only introduced at the code level and someone gets to review them, then that code turns into infrastructure that has the added benefit that there's a security checkpoint, and you're not deploying insecure infrastructure. So security requirements must be clear and easily integrated into the full process. So if you're going to, I'll start by saying that a lot of the dev teams out there, they look around and they say, hey, what do we need to do with respect to security requirements, right? And oftentimes people don't really know. What you need to do is, if you're going to achieve DevSecOps, you need to start by saying, hey, DevOps team, this is the base set of security requirements that you need to follow, you need to comply with. And OWASP provides a standard called the Application Security Verification Standard that is great in terms of giving you a set of security requirements that can be leveraged for that. No, those are very application security specific requirements. If you're looking for infrastructure requirements, there are other standards and guidelines for those as well. You also need to make sure that security review and testing must be integrated at multiple points in the DevOps workflows. So it's not just that, yeah, we're doing a security code scan in the beginning. Well, what about security unit tests and other types of active testing? What about checking container security? What about infrastructure? So you have to make sure that you've integrated those at multiple points, and they're appropriate for the type of system that you're building, and that you have an up-to-date threat model that you're using to prioritize the issues and take action appropriately. And that is actually really important, because If you don't have a threat model, what happens is that your tooling that you've incorporated, a lot of the security automation tools will produce a number of vulnerabilities. But how do you know which one of those to focus on, which one of those are false positive, what matters and what doesn't matter? If you create a threat model of your system, whenever you have a vulnerability, you can look at the threat model and say, yeah, I have this problem, I have this vulnerability, but is there a possibility, based on this threat model, that an attacker could perform an attack and leverage this vulnerability and be successful at their exploit? And if that's not the case, then you can either rule it out, so it's either a false positive or it's not important enough, and you can use that threat model to determine an impact, a likelihood, and be able to combine that with the impact on your business, which would then give you a risk level, and that risk level can then be used to treat the vulnerabilities, prioritize them, and decide what to take action on and don't, or not. And also, automation tools should produce low false positives. If you have tools that are not of high quality and they produce a lot of false positives, and that results in a lot of work for your DevOps team, what they're going to do is they're just going to simply turn those things off and not use them. And you don't want to be in that situation because you've spent all this time and money and effort to put these tools in place, and you don't want to end up having your team turn them off and not get the value. So it's important to have tools that produce good results and low false positives. You want to secure without slowing down delivery. I'll emphasize this because the whole idea is we want to be agile in a DevOps environment. We want to be able to quickly produce iterations of software and keep moving, and you don't want to slow down that process. And in order to do that, you want to do as much security as possible through automation. And you also want to do that transparently, right? Not as a blocker or blocking as little as possible. And you must preserve the agility and speed of DevOps and Agile, of the DevOps and Agile environment. And you also want to minimize manual security assessments at the end of the release. I mean, is it possible to completely eliminate manual assessments? In most cases, it's not. In some cases, it's possible. It varies, but if you do have certain things that are not going to get covered through automation and there's a need to execute a certain number of test cases manually, what you would like to do is minimize that and perform that at the end of the release, maybe every 3 sprints, every 4 sprints, depending on your environment and your compliance and security requirements. But all of this together, it adds security into the DevOps and it speeds up the release process, essentially. You want to make security easier for the dev teams as well. And so what you want to do is you want to start with secure development training. That's a really good place to start because then the developers become aware of the kinds of things not to do. I've worked with hundreds of developers, and oftentimes you see the same number of security issues occur over and over. In my first few years at the bank, I did an analysis and I realized that about the same 13 or so issues were taking place, or I was finding them on most of the applications. And that's why something like the OWASP Top 10 exists. If you haven't heard of OWASP Top 10, I highly encourage you to check it out. But OWASP puts out a list of top 10 commonly found application security issues, and that's because out there in the world, those are the same mistakes that every developer is making. So if you start by training them and say, these are the top 10 issues, make sure you understand them and equip them with the right support so that they don't keep making those mistakes. Now you've eliminated 80% of your security vulnerabilities. But you have to keep in mind that you don't want to make the developers become security experts. It's not possible or fair to ask them to do that. Development is a fairly large field and there's a lot to learn and a lot to know. What you want to do is you want to make sure that they at least understand the low-hanging fruit or the basics. So through the day-to-day process and as they're building software, they're avoiding those issues. And of course, the more difficult stuff, those are the kinds of problems that you can get assistance from a subject matter expert on the security side. You want to adopt the concept of people-centric security. You want to provide the freedom, but making staff aware of the consequences. So you really want to focus on the people, whereas before, the security team didn't focus on the people. Developers built something, and then the security team was essentially acting as a enforcement vehicle. And there was a lot of separation between the two. What you want to do is you want to say now, hey, we've enabled you, we provided you with the training, we make you aware of the consequences, and we trust that you'll do the right thing. So it becomes more of that trust and verify mindset. And of course, you've got the transparent processes and automation and everything else that you've added to the pipeline, so that in case people forget or mistakes mistakes happen, everyone is a human, that your other controls that you would put into place within the development pipeline or the processes mitigate other potential risks. And of course, as I mentioned earlier, in high-risk environments, you still have a security team that would perform some checking at certain points by designing that process not to slow things down too much. You want to empower developers to take personal responsibility for security, and you want to compensate this with monitoring them, as I mentioned, with a trust and verify mindset. And you want to use frameworks and tools to handle security, right? Because if you have every DevOps team within your organization write their own authorization code and write their own security code or tools, then you end up with having to support reviewing all of those things and make sure that they're secure. So essentially, if you use tooling that has been built centrally and then that's given to the developers, or using frameworks that deal with some of those general security problems, then developers don't have to focus on those aspects. They can focus on where they need to, which is building business functionality so that you can deliver faster to the clients and make more money and do all that good stuff. Because if the developers are spending, every team, every DevOps team is trying to figure these things out on their own, that's not a very efficient use of your time and resources. One of the things that as a lot of organizations are moving to a sort of a microservices model where you have a platform of microservices and you use an API gateway and things like that, there's a great opportunity there to use those, for example, to use the API gateway to enforce a lot of your security policies. And as developers onboard new services that are behind that API gateway, a lot of the checks are automatically handled. Or you can create libraries that your development team can consume and build into their application and not have to worry about how to deal with the security and how to build that. You want to appoint a security champion within the DevOps team. I touched on this earlier. The idea is really good. We launched this about, I can't remember how long ago it was, must have been at least 6 or 7 years ago at the bank. And the reason we did that is because we just didn't have enough application security consultants to go around. We had hundreds of development teams out there, but only a small number, handful of us in the application security team. So the idea came about that let's tell each of the dev teams to identify someone who has a knack for security. So you find someone who's got that interest and they kind of have that inkling and they like it, and you say, hey, you seem to like security. Why don't we support you in that? Why don't we appoint you as the security champion and provide you with additional training? Or when there's time for you to go to an event or take some training, why don't we focus on you doing security training? And then the job of that security champion would be to act as a primary for the security tasks and queries within the team. So anytime there's something related to a security, so for example, if one of the developers had checked in some code and the security scanner returned back and said, hey, you got to fix X, Y, and Z, and maybe it's not an easy fix and the developer needs to consult with someone to do a quick risk assessment and a threat model, the champion can work with that. But the important part is that the security champion doesn't know everything and they shouldn't be expected to know everything. And as we talked about earlier, you can expect them to learn about security as a generality and be able to address the low-hanging fruit, but you want to have that champion supported by a security subject matter expert. So in that case, if your company has internal application security teams like we did at the bank, that application security consultant can then provide support to the champion on an as-needed basis, setting up monthly forums where all the champions come together and have sort of a educational session like once a month. But in addition to that, being available to support the security champions as needed. If you don't have an internal security team, you can outsource that function to application security companies that provide that type of service. What does the security champion do? Security champion's job is to assist with rollout of security process and technologies, of course, with the help of the security SME. Within their own DevOps teams, they're responsible for assistance with risk assessment of automated security testing results. So, for example, as I mentioned earlier, if a scanner comes back and something failed when there was an automated test running, and the developer didn't have the knowledge as to what to do, or it wasn't an easy fix, the security champion can do a risk assessment and help with that. Security champion helps with documentation of security issues as well. So if the developer and the security champion did an assessment and determined that this is not a quick fix, we need to keep the pipeline moving, then what they would do is they would create an exception so that the pipeline can continue and you're not stopping development, but you would document the security issues so that it gets addressed and it gets added to the backlog appropriately. Security Champion also helps with conducting any manual test cases that are not covered by automation or getting help from an SME to do so. And they help with a review of backlog items and user stories. Essentially, in an agile development process, there are a number of items that go into backlog, and you need to figure out which of those could have a security impact. And during the design, vetting that user story and designing it, the security champion would be involved in identifying the potential problems, working with the developers or his team or her team, and figuring out, doing a quick threat modeling, figuring out the evil story, and also being able to come up with controls that take care of that evil story and making sure that it doesn't take place. Security Champion helps in threat modeling and risk assessment of changes to the design. So if the overall software design changes, the Security Champion can assist with doing that, and they can also act as a liaison between the security subject matter expert and team members. Okay, so we talked all about Security Champion and all kinds of stuff. What about training and standards in general, right? That's another really important aspect if you want to achieve DevSecOps. In terms of training, there are a number of things that you can do. We talked about the OWASP top 10 issues. I think that's one of the more important ones because those are the same issues that most development teams or DevOps teams out there are essentially ending up with in their software. So if you start by doing OWASP top 10 training and also training on what the application security principles are, and the essentially things like making them aware of the least privilege, minimizing the attack surface, and all those 10 security by design principles that OWASP has also produced a list of. That's a good place to start. Then they also want to provide some DevSecOps training. The OWASP Devs Law project is fantastic, and that's a great resource for pointing your developers to. They've got hands-on exercises, blogs, presentations, and all kinds of things that really help your developers get better at doing DevSecOps. You also want to do security awareness training. This goes without saying, and security awareness is not something you do just for the developers. Security awareness training, you do that for the entire organization, and many companies are actually required to do that on an annual basis. This is things like making sure that people understand phishing and malware and how to use things properly, not opening attachments, all those things that you think are basic. It's important to remind everybody that they're also quite important, because imagine if a developer doesn't follow those practices and the computer gets malware, their computer has access to source code. Malware could potentially inject malicious source code, and that could end up within your application's repository and then into your application. You also want to provide threat modeling training for developers. I've got a few references at the end of this at the end of this session that you can take a look at. There was a great one published recently on how to really customize threat modeling from a developer's perspective. So make sure that your developers have that training, and then of course make sure they have the support. Now, in terms of standards, what are the different standards that are important that you could leverage in order to achieve DevSecOps and make more secure applications? You can look at the OWASP Secure Coding Practices standard, which is a good place to start. ASVS is my favorite one, is the Application Security Verification Standard. It was created essentially for people to be able to test applications in a consistent manner, but those test cases are also items that can be used by developers to make sure that they're building those things, and so when they get tested, they don't have those problems, right? So you can think of it as that they're essentially a set of requirements that the DevOps team can use to build their application, and if they build it according to those controls, then when it comes to someone assessing them, then they'll pass with flying colors. So the standard actually, I think it's on pages 9 through 11, has use cases as to how it can be used, how ASVS can be used by architects and by agile teams and all kinds of wonderful stuff. Last but not least, check out the OWASP's Software Assurance Maturity Model, SAM. It's great for organizations that are trying to move from a DevOps model to a DevSecOps model, and they want to bring security into the overall software development practice. And you can use it essentially to figure out where you're at now, to capture your baseline, and then create a roadmap in terms of what I want to do to achieve next year, the year after that, in terms of governance, architecture, automation, and all the other facets of that are required in order for you to have security embedded at all the different stages within your development lifecycle. So this is a typical development lifecycle. Typically, this was designed for the waterfall model. Microsoft, back in 2002, they realized that they were getting a lot of flack from the industry in terms of, hey, Microsoft products are not secure, and everybody was giving them a hard time. So Bill Gates at the time said, hey, let's drop everything and let's launch this trustworthy computer initiative. And out of that, the secure development lifecycle was born. At the time, the development lifecycle was more waterfall oriented. So they introduced the security counterparts at each stage within the waterfall SDLC process. And as you can see down here, with during the requirements stage, you would have establishing security requirements. During design, you would establish design requirements or analyze the attack surface, do threat modeling. During implementation, you had some tools and you would do static analysis. During verification, you would do dynamic analysis and fuzzing and attack surface review. And then finally, when you released it, you had your incident response plan and doing a final security review and release archive activities. Now, as we've gone into more of an agile or DevOps processes that want to incorporate security, this is what things look like. And I didn't write out the activities that are DevOps or Agile practice activities. The focus here was on what type of security activities do you add during each of these stages. So if we look at a typical Agile DevOps phases, the first one is inception. And during inception, from a security perspective, what you want to do is perform a business impact assessment to figure out if this system blows up, if someone attacks our system, what would be the impact from a business perspective? What kind of data are we storing, or what kind of functionality does this provide, and how would that impact our business? That information can then get used to make decisions with respect to false positives or what actions you take, even with respect to monitoring and alerting. What should I be monitoring and alert on? Should I be raising an alert for a low risk? Absolutely, maybe not, maybe yes or no. For high risk, definitely, absolutely, right? So if you have a threat model and you know what the potential issues can be, and then you can overlay the impact and the likelihood, and then figure out the risk. And based on risk, you can make decisions in terms of implementing preventative controls or detective controls, and so on. You also want to select security automation tools during inception. So figure, hey, we're kicking off a new project. These are the tools we're going to use. And these are the gates that we're going to introduce at the different stages within our DevOps pipelines. And you want to determine the security requirements. And as I mentioned, ASVS is a great source for that. And you want to essentially go through that and figure out, okay, what is in scope and what's not, and take the controls that are in scope and somehow add them to the backlog. Some of those might be architectural controls that need to be sort of incorporated across the entire system. Some of them may be specific things that can be put into different sprints. And you also want to agree on how each security requirement is going to be tested, right? So right up front, yes, we have these security requirements. Well, how are we going to assess them, right? Are these things that we can do through dynamic testing, or is this stuff that can be covered through static analysis, and so on and so forth? You also want to provide secure development training to your developers, as we mentioned earlier, at the minimum OWASP top 10 in threat modeling. Then when you go to the next phase, which is planning for the iteration, you want to select security work items from the backlog. So now you're in the planning stages for that iteration. You're going to be taking some items from the backlog, and that's what's going to get built from a functionality and business perspective. But you should also be looking at the backlog from a security perspective and figuring out what items make sense to add to that particular sprint. And during planning and iteration, you want to review the groomed backlog lock items and identify user stories with security impact. Because as the business analyst refines these and grooms them and adds detail to this stuff, the security champion or the team members should be looking at those user stories and determining which of these could potentially have security impact, and making sure that they've identified the evil story, as well as the happy path, and then have we got a problem or not? If the evil story results in a realistic attack scenario, then are we going to design the right control that goes along with it to make sure that the problem doesn't take place? Then when you go into the development and on the design side, you want to perform security design review, threat modeling and risk assessment, and solution design related to user stories identified as having some security impact. So that's kind of what we talked about, right? So during the previous stage, during planning, you identified these groomed backlog items. They can have some security implication. And then when you go to design and build it, you make sure that you threat model it, assess the risk, and then build the appropriate control or design the appropriate control. And then you go into the development, the code and build stage. That's where the developers are now actually creating the code. So what kind of security things can you do there? Well, you could have security plugins for the development environment IDE, so that as the developers are creating code, it highlights, hey, maybe you shouldn't be using the RAN function in Java. Maybe you should be using the secure SRAN function in Java, or and other things that are related to mistakes or errors that could be done, that could be introduced while the code is being written by the developers. And then, of course, when the developers check their code in, you can run automated SAS, which is static application security testing tools, as well as vulnerable dependency checkers, or VDC, on those pull requests. So at that point, the developer is checking some code and doing a pull request. You run an automated security scanner to make sure that there are still no secure issues that were introduced in the code, and the VDC will help will help determine if a vulnerable module or library is being added to this application. It basically, most of those tools, such as OWASP dependency checker, they will look at known CVEs and known vulnerabilities and components, and then they look at your dependencies and identify, hey, you are including certain dependencies. These are deprecated, or they have known security vulnerabilities. You should go and update them. So, and then you also want to fix identified issues where possible, and otherwise add them to the issue tracking and register, and then proceed. Again, the whole idea, as I mentioned earlier, is not to slow down the development. You don't want to say, oh, wait, the security tool ran, and now I've got this this library I need to update, it's telling me, but this is going to break a lot of things within the application, right? So you don't want to hold everything up. You want to have a risk-based approach so you can fix things where possible. So my recommendation is usually, if it's easy and it's a quick fix, just do it, right? But you want to maintain that zero defect or zero security issue baseline that we started with at the beginning of the project. And what you want to do is, anytime as a developer you're checking something in, if you introduce that vulnerability or the security issue and it's a quick fix, just fix it. If it's not a quick fix and you determine this is complicated, it's going to high story points, and it's going to break the application or impact other pieces, other aspects of the system, you create an issue, add it to the backlog, write it in your security register, and move on. Now, if you did the risk assessment on that and it was high risk, in some cases you may not want to move on. You may want to have that conversation. But again, as I mentioned, you can fine-tune this process based on your organization's risk appetite and compliance requirements. And you can see down here this red arrow, security training and knowledge sharing, right? This should be an ongoing process. So your developers are always sharing lessons learned, and also they're getting the right security training. What about during the integration process, right? So now they've built it, they've coded it. Now it's going to the integration process. Oftentimes on the QA side, you have integration tests and you have integration environments, and you do that on QA. With security, you want to run automated SAS, VDC, and DAST. And you might ask, well, why am I running SAS and VDC again? Well, just as a secondary check. Those types of activities don't take a lot of time. They're very quick. So sometimes something may have fallen through the cracks. Maybe a developer turned off the SAS on their side, heaven forbid. But you want to run those again. But the main thing that you do during integration testing is DAST, which is dynamic application security testing, and that's similar to the other non-security tests that are done in QA in principle. Essentially, you stand up a running copy of the application in a staging or a pre-production environment, and you execute. You interact with the application. The difference between QA is that in QA you typically test to see, is the function working? Is it doing what it's supposed to do? Maybe you test for failure, do some performance testing. On security side, you test the running application to see, hey, can I send it vulnerable payloads, and will it realize an exploit? For example, can I send it some payloads that are related to SQL injection and be able to compromise the SQL database by being able to receive data from it, or delete data, or modify data, and so on and so forth. So that's quite important to do that during integration, and you want to fix identified issues, so similar manner where possible, but otherwise add them to the backlog. So if it's a quick fix and you can do it, do it. Otherwise, add it to the backlog, or take the right next step based on your risk appetite and profile. When you release something, so during the release and deployment phases, what you want to do is you want to perform threat modeling to identify any possible gaps. So you've now done the initial threat modeling on the high-level architecture, which helped you with false positives and which helped you prioritize issues. You've been doing incremental threat modeling during the development stages, but here when you release something and you deploy something, you also want to do that threat modeling one more time to see is the design of what went into production, is it different, and what are those design changes, and have I created threat scenarios for those to make sure that I didn't miss anything. And you also want to conduct manual testing. So this is a good time to cover any test cases that were not covered through your automation. So when you went through the ASVS and you determined what is in scope and what's not in scope, and you said, okay, I've got 100 controls that are in scope. Out of those 100 controls, I have been able to roll out automated testing to address 70 of them, but these 30, I couldn't really create automation for that in order to be able to test it. So perhaps every X number of sprints, or every time you put something into deployment, that you also execute those manual test cases. You also want to run, when you put something into the deployment, you also want to run automated SSL testing, network testing, and other scanning like container scanning and things like that to make sure that, again, what you've put out there doesn't have security issues from the infrastructure perspective. And similar process, right? You fix the issues where possible, otherwise add them to your tracking and risk register and appropriately deal with them based on risk. And the final phase in the DevOps phases is the operations and monitoring phase, and that's ongoing. So essentially, on an ongoing basis, what kind of stuff can you do from a security perspective? You can run IaaS, RASP, WAF, infrastructure scanning, sending data to a SIM. And what are those things? IaaS and RASP, they basically are types of tools that incorporate themselves within your application, so they can monitor the application as it's running. Between IaaS and RASP, they're slightly different. One of them is more about protection. RASP is more about being able to protect as well, whereas IaaS is more about recognizing and detecting that there's something going on that potentially could be a problem within your application from a security perspective. But they're real time. So oftentimes the argument is made that real-time tests are better than static tests because stuff that you're doing before the application is running, or from an outside perspective, even with dynamic testing, right? Dynamic testing is during, it takes place while the application is running, but it's from the outside. And you don't really know what is going on within the inside of the application, so it doesn't give you the same view. Having something like IaaS and RASP inside the application gives you an inside view. So then it reduces the false positives even further. The ideal situation is having all of it, right? Having a comprehensive set of security tools that are covering stuff from the outside, such as SAST and DAST and VDC, and as well as IaaS and RASP from the inside of the application. And of course, web application firewalls are quite handy because they help you with ensuring that various if your application isn't hardened, or maybe something got missed, the web application firewall can still monitor the traffic that's coming into your application and be able to identify potential web application vulnerabilities. But again, keep in mind, because the WAF is sitting outside your application, it might see that there is a bunch of malicious characters. For example, maybe someone is trying to do SQL injection on your application, but it won't be able to see whether that exploit succeeded or not. Because yes, sure, you saw this packet that went through the WAF and it had malicious SQL characters, but maybe the application had protection, maybe the application was using an ORM and it was hardened to protect itself from SQL injection. So WAF is a nice to have. It's not going to solve all your problems, and it won't give you as much of an accurate view. But again, all of these things are part of the bigger picture and stuff you need to put together to get that comprehensive coverage. You also want to maintain an up-to-date threat model and have detection use cases. So as I mentioned earlier on, that threat modeling not only does it help you make the right decisions with respect to reviewing the security scan reports and assigning risks and identifying potential problems with your design and being able to identify those evil stories and again figuring out what to do. Those are all preventative measures on that side, but also on the operations side, the threat model can help you figure out what are the use cases in terms of monitoring that you should alert on. So if you have, when you've done your threat model and you've identified all the threat scenarios along with risk levels, you would then create use cases and detection rules Obviously, definitely for the high-risk items, and then for the medium ones, and then possibly for the low-risk ones. But it depends on how much noise you want to get. You may want to fine-tune that model. So you also need to determine areas of application security improvement and add that to the backlog. So when you're in the operations and monitoring phase, you might notice certain things that could have been done better, and you want to make those observations and then add that stuff to the backlog so that in the next iteration or in the future iterations, the developers can build those for you. You want to provide training to target areas of weakness. And you also want to have that support. As I mentioned, for companies that have their dedicated security team, that security team can provide support as needed, and so on. What about continuous automated security testing? So 3 important things. Don't wait until the end of the release to perform a detailed security risk assessment. That's just not a good idea. That's how we did things when I started in this business back in the late 2000s. Essentially, what teams were doing is they were building everything and then coming a year into it to the security team say, hey, can you do an assessment on this and can you test it? We would go back with a long list of problems and say, hey, yeah, we tested it. You've got all these problems. And then either they would have to delay the release, so now they've waited a year, and now they'd have to wait a few more months to fix all those things, or they would release it without fixing those, which was not a good place to be. So it's really important that all the things that we've talked about, adding security into your DevOps model, really enable in a situation where you're not waiting until the end of the release to do the full assessment. Security tools should be integrated into the CI/CD pipeline. Really important. You don't want to take the process outside of the DevOps pipelines, right? You don't want to have a system that's separate that what the developers are using. Whatever tooling, CI/CD systems, or those types of technologies that the development team is using, your security dashboards, tools, whatever it is, need to be a part of that, not a separate place. You don't want developers to come to you to ask for, hey, what was the output of that scan? You want to have that scanner put the output of that scanner be a build artifact that goes right into the that the developers have access to and can quickly leverage to be able to make a decision and move forward. And the integration allows low-hanging fruit to be caught earlier and regularly, right? That's the most important thing to keep in mind. And you don't want to have that stuff being dealt with later on. What about open source CI/CD security scanners? So I'm sure you're all wondering, okay, Farshad has been telling us about all these things we need to incorporate. What options are available? And we don't have a lot of budget, right? Of course, there are a lot of commercial tools, but in terms of open source, here are a number of things that are quite useful that you can leverage and put into your CI/CD environment. In terms of, I broke this out into 2 different areas, application versus environment, meaning infrastructure and everything else that goes with it. On the application side, there's 3 different areas of concern that you need to address, right? You need to do static code analysis. You need to look at all the libraries and whether they have vulnerabilities. Those libraries, you may not have the source code, right? They're NPM packages or maybe a library that you downloaded from some open source project. And then the third one is the dynamic application security testing. So those are the 3 types of things you need to do. And for each of those, there are a number of different options available. So for SAST, if you're a Java shop, there's FindSecBugs, which is a great tool. If you have Python, there's Bandit. If you're Ruby shop, there's Brakeman, and then there's of course SonarQube that supports 20 plus languages. Now the community edition of SonarQube is not as strong on the security side, but it does a decent job. So if you are a Java shop, I would recommend using FindSecBugs. But Brakeman for Ruby or Bandit for Python. But if you are using something else like .NET or heavy on the JavaScript side and one of these other dedicated tools don't address your needs, then SonarQube can help. Now, I'll say another thing is oftentimes the recommendation is if you use more than one tool, it helps you with determining false positives, because if you're just running one tool, then it's one tool's opinion. But if you run 2 tools, then you can look at the outputs and you can see how they differ. But also one tool may find an issue that the other one didn't, right? So false positives aside, it also helps you find more relevant problems. So if you can afford it, in terms of, these are free, but if you can afford it in terms of putting it all together, or if you want to, I would highly recommend that you use more than one tool where possible. In terms of vulnerable dependency checking, OWASP Dependency Checker is fantastic for Java and .NET. We did some comparisons. Yeah, it does produce slightly higher number of false positives than some of the commercial tools like Sneak, Mergebase, or Black Duck, but it is pretty good for a free tool. There's also bundle audits for Ruby. There's Retire.js for JavaScript. So all these are really good options. And then in terms of dynamic application security testing, there's really one that I highly recommend is OWASP's Zap. This was created by Simon Bennett, who was also I believe he was a developer himself and wanted to incorporate automated testing into his CI/CD pipeline and didn't find any tools that were that good for that. So he rolled up his sleeves and started this project. I think it's a fork or it's offshoot of Paros. But great tool. It has an API, an ability to load Swagger and Opium API definitions, and it's really designed for security automation. A lot of AppSec practitioners use tools like Burp. Those are great for manual testing, whereas they can also do some automation. They have plugins for it, but they're not really strong on the automation. But whereas Zap may not be so great as a tool for manual pen tester, but you can still use it. But Zap was really designed to go into a CI/CD environment, and it's free, which is what we use. And we've actually built some technology around it that wraps it all in a container and helps with ease of deployment for all of these different AppSec tools. What about environment security? So you've got your infrastructure, your containers, or your the virtual networks and all that kind of stuff. OpenVAS is similar to Nessus. In fact, Nessus, I believe, was a fork of OpenVAS. It's great for making sure that you just do a quick scan so that you don't have ports open that shouldn't be, right? So you've stood up the application. Maybe someone accidentally added something that shouldn't have been there. So it's important to do that check on the running application to make sure from a network perspective that it doesn't have anything that it shouldn't. And then there are things like Anchor or Claire. Claire can scan Docker containers in case you are using them to make sure that you haven't consumed any Docker containers with vulnerabilities. And finally, it's important to do some TLS scanning, because I'm assuming and I'm hoping that all of you out there building applications are using TLS, but it's important to do a scan to make sure that your environment doesn't have any deprecated ciphers, older versions of TLS that have vulnerabilities, and you pass based on current recommendations and what is considered to be secure. So, as I mentioned, there are challenges with multiple scanners because when you have, as you saw here in the previous slide, just if you go based on this list here, you'll have 5 different types of scanners, right? So let's say you use Find Sec Bugs for SAST, and you use OWASP Dependency Checker for your VDC, and you use ZAP for your DAST, and you have OpenVAS for your network and SSLIs, right? You ended up with 5 different tools here. So now think about it. You're going to have to install these in your build agent, and then if you have multiple build agents, all these have to have all the tools installed in them. Then you have to maintain them. So, okay, you use VMs for your build agents and you manually install these tools. But if you have like 10 build agents and all these repos, you have to install it in all these different machines. Yeah, okay, maybe you could automate it using Ansible. There's still a bit of work involved there. And then you have to continually keep them up to date and maintain them and patch them and all that stuff. There's a lot of work. There's also no global configuration switches because you got 5 different tools, and each of them, although they kind of do something similar, you have to manually configure them. There's a lack of central error logging. You'll end up multiple reports in different formats in different places. And as I mentioned, installation, maintenance, and patching of these tools becomes complicated. So that's one of the challenges. And as I mentioned, we've created technology that bundles all these things. We use the framework called Salus that was created by Coinbase, and that framework allows you to aggregate multiple security scanners. So we've built upon that and tried to address some of these challenges. And you can reach out to me if you're interested in finding out more about it. So that brings us to the end of the presentation, and I'd like to thank you for attending or for checking out the session. At the end, I just want to highlight, there's a slide here. I've got a bunch of resources that I've mentioned some of these during the presentation. Things like the threat modeling for developers on Martin Fowler's website. That's a great article. It came out about late May 2020, so it's fairly recent. GitLab's DevSecOps processes assessment is really good to figure out where you sit within your DevSecOps journey. If you've started it out, it's a good place to measure yourself and help build that roadmap. And the OWASP SAM can also help with that. The DevSlot project is great for getting your developers to learn more about DevSecOps practices. OWASP security coding practices guideline is a good place as a quick reference for your developers in terms of what to do from a security requirements perspective, or ASVS, which is a more fleshed out set of requirements for DevOps teams to use. Find SecBugs, SonarQube, Bandit, Brakeman, all great tools, as well as OWASP dependency checker. So that brings us to the end of today's presentation, and I'd like to thank you once again. You can connect with us, email us at comms@forwardsecurity.com. You could connect with us on Twitter at forward_sec, and you could check us out on LinkedIn, linkedin.com/company/forwardsec, and of course our website forwardsecurity.com. Feel free to reach out to me if you have any questions. I've got lots of experience having worked with teams over the last 10 plus years, and I'd be happy to answer any questions that you might have. Thank you and have a wonderful day.